Hello, welcome to our channel for R programming. In this video, we will talk about Levene's test for homogeneity of variance using R. So we know in statistical data analysis, very often in many models, we have assumption that the data are homogeneous variance. That means this y variable at different values of x variable. For example, x variable is a constant. Y variable here is linear. And for different values of this horizontal range, the y value has almost equal variance. So this is called homogeneity of this variable in terms of this variable. If we look at this figure, it's very clear for different values or different categorical values of constant, the y range is different, right? More spreading for this category than this one. So this is heterogeneous of variance. And we have to test first of homogeneity before we can go further to use many statistical models. So this is the hypothesis testing H0 or null hypothesis, that we assume odd variance of y value in terms of different categorical x variables are the same. And if the test is significant, so we will reject H0 and will in favor of H1 or alternative hypothesis that at least two of categories have different variance of this y variable. In R, if you want to test the homogeneity, so this is called the Levene's test. We have to use car library, then use the function leveneTest. So the form of the test is quite simple. You just write the variable of y here and with the tilde, then with the variable x on the right side, then comma with the data frame. So this is data frame. So this variable comes from this data frame. So next we will show several examples in RStudio. So first we show a data set from dplyr package. This data set called plant growth. So we just show random 5 sample of this data frame. So you can see the 5 random samples, they have weight and group variable. Next, we load library car. Then we want to test the homogeneity of weight in terms of group. So we have to test for different values of this categorical variable group. You can see the value TRT1, CTR1, this is a different value. So for different values of group, if the weights has same variance, then we just run leveneTest weight tilde group, then data set is plant growth, and the results are assigned to the result object. Then we print this result. So you can see the variance homogeneity test results is based on F statistic or F test, and it has degrees of freedom 2 and 27. So F distribution has 2 degrees of freedom. And the test result, we look at this value and p-value. So most important is p-value. So p-value is 0.34. It's much larger than 0.05. So the test is not significant. Or say we will hold this null hypothesis. So we will not reject the hypothesis that the variants are homogeneous. Or say we will hold this statement, the odd variants are the same in terms of different categorical variable. And the Levene test can also be done on multiple independent variables. Say we also show the variable print two screws. You can see that this dataset two screws has two categorical variable, dose, soup, and with the length continuous variable. So usually the independent variable should be categorical and dependent variable should be continuous. And we load library car. Then this time we will test the homogeneity of length in terms of different value interaction between soup and dose, and from the data frame two scrolls. Then we print the results. This time the test statistic F value is 1.7 and for the degrees of freedom is 5 and 54. Then the p-value is 0.1484. It is also larger than 0.05. So in this example, we also do not reject the null hypothesis of homogeneity. So we also hold this statement that odd variance of length in terms of different categorical values interaction between soup and dose have the same variance. Thanks for watching.